Hey everybody, Mr. Longo here, and this video is going to cover piecewise functions. Piecewise functions look a little different because there's actually multiple functions wrapped into one, but they only occur at certain constraints. So 2x minus 3 only occurs if x is less than or equal to a negative 3. As soon as you are greater than negative 3, you are now going to enter the x plus 1. But x plus 1 only occurs if x is greater than a negative 3, but also less than or equal to 5. So anything in between negative 3 and 5, including 5. And then finally, if you get to anything larger than 5, 6, 12, 10,000, it's going to be 7. Okay, so a piecewise function has different values. It uses different functions at different increments of x. Okay? So let's take a look. If we were going to evaluate f of a negative 5, that means we want to know what is this function's value when x is negative 5. So the first thing you need to do is go find which one of these three functions you're going to substitute the negative 5 in. So is negative 5 less than or equal to a negative 3? The answer is yes. So what you're going to do is you're going to substitute the negative 5 into the first of the three functions. So we have negative 10 minus 3, so f of negative 5 is a negative 13. Okay, that is the value at that time. So if we were going to go try to evaluate the function when f is negative 3, now we have two negative 3's here. We have negative 3 is less than x, and we have x is less than or equal to a negative 3. When you are evaluating one of the numbers that is one of your constraints, you need to be very careful. And in this one, we need to pick negative 3 is less than or equal to the negative 3. So again, we're going to substitute negative 3 into the top function. So we have 2 times a negative 3 minus 3. So that's going to give us a negative 6 minus 3 is a negative 9. Okay? So that's how you evaluate a piecewise function. So the next one, if you're going to find f of 2, the first thing you do is ask yourself, is 2 less than or equal to negative 3? The answer is no, so you move on to the next set of constraints. Does 2 land in between a negative 3 and a 5? And the answer is yes, it does. So you're going to substitute 2 into this function, the middle one. So we have 2 plus 1, so f of 2 is equal to 3. And I'm pretty sure you understand by now. So the last one, f of 8. Is 8 less than a negative 3? Nope. Is 8 in between negative 3 and 5? Nope. Is 8 greater than 5? Yep. So anything in this category, the answer is just 7. So f of 8 is equal to 7 because 7 is just a constant. Okay? So that's an idea of what piecewise functions are. So evaluating them is pretty simple. So what about graphing them? We're going to graph that exact same function. Now there are so many different ways you can do this. I've seen all sorts of different tricks. I've seen highlighters, I've seen shading, I've seen vertical lines, I've seen checkpoints. I've seen people use the calculator. Really, as long as you graph it correctly, it's fine by me. You can use any method you want. I will show you a little tip that you might find helpful when you are graphing piecewise functions, and that is to look at your constraints. Remember, we have a constraint at a negative 3, and we have a constraint at 5. Now, one tip that I have found very helpful for students is if you draw a dashed vertical line at your constraints. So you have a negative 3, and we also have a constraint at 5. Now, those lines represent an area where you can never graph more than one line. So you have the left region, the middle region, and the right region. You are only allowed to have one line graphed in each of those regions. That's why the vertical lines are sometimes helpful. Because remember, these are functions. So after you graph them, they need to pass the vertical line test. Okay? So, let's start graphing. I'm going to start with the middle one, just to show you that if you have a start and a stop, it's pretty easy to graph. So if you have a -3 as your starting and 5 is your ending for this particular constraint, then all you have to do is plug both of those into the function to get a start and a stop point. So if we were to just take the -3, comma, substitute -3 in here, -3 plus 1 is -2, that's our starting point. And then our stopping point is 5, comma, whatever you evaluate. So 5 plus 1 would be 6. So those are our starting and stopping points. The only thing we have to do is be very careful of if they're open circles or closed circles. So it does not include the -3, but it does include the 5. So let's go graph those 2 points. We have -3, comma, -2, and we're going to put an open circle. And then we have a 5, comma, 6, and we're going to have a closed circle. And then all you have to do is connect those 2 dots. Okay? So when you have a start and a stop, it makes things a lot easier. But it's the ones on the end that are sometimes a little bit trickier to do. So I've seen many different ways that students have done these in the past, and I'm going to show you the way that most have said they have found the easiest. And what you do is if you have a start and a stop, these are going to be your start points, because the other ones we're going to call go-to points. So we're going to start at -3, comma, something, and that -3 is, we just substituted in here, -3 times 2 is a -6 minus 3 is a -9. And it is included, so we're just going to go graph that right now. -3, -9, that is our start point. But what you do is you choose a go-to point of your own, and you want it to fit on your graph somewhere. A lot of times we keep them pretty close. So if we're going to have a -3 as a start, then we want to move over a little bit, and let's just say we're going to go to -4, comma, something. And -4 times 2 would be a -8 minus 3 is a -11. So we want this graph to head towards -4, -11. So that's -4 and slightly off the graph, -11. And then we're just going to graph a line in that direction. Now, why did that happen? That's because it has a slope of 2. If we have a slope of 2, we're just going to go down 2 over 1, down 2 over 1, if we are going in the backwards direction, okay? And then if we're going to do 7, if x is greater than 5, we know that 5, comma, 7 is our start point, and it does not include the 5. So 5, comma, 7, open circle. And we want to choose a go-to, and we want that to be somewhere greater than 5. So let's just go to 8, comma, and then since it's always 7, we're going to go to 8, comma, 7. And we're going to plot a dot and draw our line, but we go past it and we put an arrow, just like we did in the first one. Okay? That's just a way to make graphing these a little bit simpler. All right? So, now that you know how to graph and evaluate, why don't you pause the video and try this guy on your own, and let's see how you do with it. So let's see how you did. Over here we have our starting point, which is -5. And we substitute -5 in here. We have a -5 times 2 is a -10, plus 6 is a -4. It is not included because it just says less than, so we're going to graph -5, comma, -4. And we're going to put an open circle. Now, since this only occurs when x is less than -5, go pick another number where x is less than a -5. And we're going to go to -7 is what I'm going to pick. You could have picked whatever you wanted. So -7 times 2 is a -14, plus 6 is going to give you a -8. So we're going to go plot the point -7, -8. And that is our go-to point. So we're just going to draw a line through it and put an arrow. Now again, if we were to go back and check 2x plus 6, that's our 2x is our slope, so 2 would be up 2 over 1, up 2 over 1. So you can see that the slope is still consistent. And then if you were to go up 2 over 1, up 2 over 1, and if you were to continue to do this, you would land at 0, 6, which would be your intercept. So if we were to continue, which we don't want to, but if you were to continue, you would see that it's just the graph of the line 2x plus 6, but we only graph it less than -5. The 2 in the middle. Here's our start, -5, -4, and our stop, 2, -4. So we're going to start at -5 and include it, -4, which is right on top of this one, so that guy gets colored in. And then we're going to go all the way till we get to 2, -4. This one is not included, and you just draw a horizontal line to connect the two, because remember, a constant, f of x is equal to -4, is just a horizontal line when y is equal to a -4. And finally, we're going to finish up with our start point of 2, -1/2 of 2 is 1, which is a -1. Add 3, and we get 2. So we're going to start at 2, 2. Now we need a go-to point, so we're going to go to. Pick any number that is greater than 2, but you might want to keep it even since we're going to need to multiply it by a -1/2, so we'll call it 6. So -1/2 of 6 is a -3 plus 3 is 0. So we're going to go to 6, 0. And again, that is our go-to point. So if you were to just look at the slope, down 1 over 2, down 1 over 2, you're going to hit that point anyway. And then if you go down 1 over 2, you're going to continue in that direction. So we draw a line through it, put an arrow, because this continues. The go-tos continue. The ones in the middle, they have a start and a stop. All right, so that's it for Piecewise Functions. This is Longo, and I'm out. See you, bye.